In this video, we're going to talk about side-side-side triangles with the law of cosines from 7.3. It does not matter which version of the law of cosines you want to use because we're going to be solving for whichever angle you want to solve for. I recommend that you solve for the angle across from the biggest side in case it's an obtuse angle, that the law of cosines will give you that. So I'm going to do that and say that this is going to be 6 squared is equal to 5 squared plus 4 squared minus 2 times 5 times 4 times cosine of angle C. So thinner. 36 equals 25 plus 16 minus 40 cosine of C. So this is 36 minus 25 minus 16 is a negative 5 equals a negative 40 cosine of C. So 1/8 is equal to cosine of C. Arc cosine of 1/8 gives me C is 82.8. That's my biggest angle there. So now we can use the law of sines going forward. So I have sine of 82.8 is to 8 is to 6 as sine of A is to 5. So sine of A equals 5 sine of 82.8 over 6. So A is arc sine of 5 sine of 82.8 divided by 6. A equals 55.8. 180 minus 55.8 minus 82.8 is going to give me 41.4. If you want to double check that with the law of sines, you can. You should get that sine of B over 4 equals sine of 82.8 over 6. So 4 sine of 82.8 divided by 6. Arc sine, second answer, should give me 41.4. All right, moving on to the next problem here. And again, I'm going to solve for the angle that's across from the largest side. So I'm going to have a squared equals b squared plus c squared minus 2bc cosine of a. 11 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cosine of angle A. 121 equals 25 plus 49 minus 70 cosine of A. 121 minus 25 minus 49 is 47. And so 47 divided by negative 70. And then second cosine, second answer So we get A equals 132.2. That avoids anything with the ambiguous case now that I have my obtuse angle here. And let's use the law of sines now. Sine of 132.2 over 11 equals, let's solve for angle B. Sine of B over 5. Sine of B equals 5 sine 132.2 over 11. So arcsine of 5 sine 132.2 divided by 11 gives me 19.7 for B. 19.7 plus 132.2 is 151.9. 180 minus that answer gives me 28.1. Let's move on to the next problem. A, B, C. And C is 25. B is 20. A is 15. I'll solve for angle C first since it's across from the biggest side. 25 squared equals 15 squared plus 20 squared minus 2 times 15 times 20 times the cosine of angle C. So 25 squared minus 15 squared minus 20 squared is 0. So 0 equals -2 times 15 times 20 cosine of C. So all of this cosine of C equals 0. And then that means that C is going to be 90 degrees, even though it's not written that way. So let's drawn that way. Let's draw it as a right triangle here. So this is 25. This is A and B, and this is 15, and this is 20. It's a 3, 4, 5 right triangle that's been scaled by a factor of 5 is what's going on here. So now we have arcs, let's see, sine of A over A is equal to, it's a right triangle. So sine of A equals 15 over 25 equals 3 over 5. So A equals arc sine 3 over 5. Is 36.9 degrees, and 180 minus 36.9 minus 90 is 53.1. Makes sense to me because it's complementary to 36.9. Let's look at number 4 here. A, B, C. They're all equilateral. They're all 6. So don't really need to know anything other than equilateral is equiangular. And these are all 60-degree angles. I can solve for it with trigonometry, but that's a geometry problem, basically. Let's prove that to you, that 6 squared equals 6 squared plus 6 squared minus 2 times 6 times 6 cosine of, let's just pick A. Okay, so 36 equals 72 minus 72 cosine of A. Negative 36 equals negative 72 cosine of A. 1/2 is cosine of A. A is equal to 60 degrees. Cosine of 60 degrees is 1/2. And then we could go from there and use the law of sines, and we'd see that the next angle would have to also be 60 degrees, and then 180 minus 120 would be 60 degrees. You get the idea. But that's it. We'll come back next time, and we will be talking about the applications of the law of cosines next time. So see you for the next video.